left. So back to stoichiometry. Fun stuff, right? It's your favorite. I don't know. I hope if you guys didn't lose your power, you were able to catch yourself up. I think Wednesday, since it's a half day, is the plan is to have kind of a catch-up day, so we'll be able to kind of handle some stuff. All right, so if you open up your folder, I put a little Snowvid 21 folder in there. It's empty, but it just says school was canceled whole week. Yay. So I did put this folder in just now. So if you want to join me on the actual assignment, you can go ahead and open up that. There is not, I was in the process of working on putting on like the Jamboard link and this little image that I'm about to show you. It's all going to be there as well as all the videos. So if you need to go back to it this week for later, you guys can definitely come back to this folder, and there'll be all the resources from the week before. Sorry. But for today, just go ahead and open up the assignment. That way you can work right along with me. I did rearrange something, so I'm hoping it works for y'all. It didn't for first period, so let's see. We're going to let that load. Let me see if it rearranged for y'all. It did. Okay, cool. So we're going to be going through this, and like I said, you guys will have certain questions that you got to do on your own, okay? So let's go ahead and dive into this. Oh, wait, before we do that, let me show you what we ended with, right? So we had all of this. So just a reminder as to what we were focused on. We had stoichiometry, which was traveling between a mole town and a gram land, right? Mole town, gram land, by dividing by molar mass or multiplying by molar mass, depending which way you're going. But remember, I told you guys don't focus too much on that part. What you want to focus on is words down to the right, and it tells you what to do, right? So remember that we had a mole ratio that showed up in every single one of our calculations, right? Mole ratio is in every single calculation for stoichiometry. It's absolutely necessary because that's how we relate to things. Whenever we're in mole town, we are crossing that bridge. That is that mole ratio, and then we can travel back if we need to. So you're going to see this question on number 2. We're going to get to this in just a second, but I wanted to show you this is what we've done. We did all 4 of these before the whole Snowvid thing, right? So we had so here what we have is we have our mole to mole calculation. So that was where we started with moles. Words down to the right. Don't forget that. Okay? And then we cross that bridge, or we relate it with that mole ratio. So who remembers where the mole ratio numbers came from? Where are we going to grab those numbers from? Mole ratio. Okay, not the periodic. I've gotten a couple people say periodic table. Not the periodic table yet, right? Mole ratio. This is where we have the mole to mole thing. So we're going to be grabbing that coefficients. Perfect. Yes. All right. So mole ratio was our coefficients. Okay. And then when we get down here, mole to gram and gram to mole, those were just opposites of each other. We had our moles, brought them down to the right. Coefficients, brought it down to the right. Now we're doing that conversion thing where we're grabbing from the periodic table. And then the gram to mole, which is up here. You see words come down to the right. Here's our conversion. So 1 mole to molar mass. And we bring words down to the right, coefficients again. And then remember, the last thing that we ended with before you guys left was the gram to gram. Oh my gosh, it's so scary. It's not. It's the same setup every single time. So really, and if I have time by the end of the day, I'm going to give you guys a little tutorial. I was hoping to do that, but I lost all my power, so I didn't have any time. So, but we were trying to, I wanted to show you guys that you just look at this gram to gram, and it is all 3 of these calculations. So if you just use that as your setup, and you just kind of shift to the left or to the right, it's the same thing every single time, and it shows all of these, okay? All right, so let's go ahead and go straight over to that assignment because I know you guys are waiting on me. So it says, think back to, we are on number 1. Sorry, we're on number 1, so go ahead and have it open. Think back to waffle stoichiometry. Match the definition with their correct terms. So looking here, waffle stoichiometry was when we had the recipe of the waffle, we had eggs, milk, all that good stuff, and we didn't necessarily, sorry, I don't know what I was saying. What we saw happen was that we had possibilities of how much we could make, but the eggs kind of stopped it, right? So the eggs ran out first. Which of these definitions sounds like a limiting reactant, which is what the eggs were? Good. Someone said the first one. Yes. All right. So reactant that is used up and stops the reaction is going to go into that first box. So then process of elimination tells us the one that has leftovers is your excess reactant. So hopefully you guys got both of those. Okay. Number 2. So number 2 is where I need you guys really focusing. Okay. And this is the whole point of today. So it looks really scary. I know that that's a lot of words, but I'm going to show you how to do this easily. All right. So it says read the following stoichiometry problems and match their type. Match them to their type. You want to focus on the given and the question in order to recognize it. Because remember what we're looking at, and I'll kind of just scroll down here. You have gram to gram, meaning you start with grams, you end in grams. Mole to mole, start in moles, end in moles. Mole to gram, you start with moles, and in grams. So just kind of remember back to our basics, like what were we focusing on in these problems? So for example, the first one that we have here, it says how many grams of KClO3 are required to produce 7.5 moles of this? All right, so what if you guys had been given this problem, what would be the first thing that you would put into your little problem? What part would you pull from this question and put it automatically into the problem? 7.5, exactly. So don't worry about the words so much. Look at what, just go back to your basics, right? That's the part that we would have pulled. We would have said, okay, well, then I have 7.5 moles. And then you want to know where you're trying to go, right? How many grams? That's where we're trying to go. So what we had been doing before we left, let's see here, I had underlined where we start, circle where we go. So this would be a moles heading to grams, all right? So what you're going to do is you're going to pull from down here, we're going to say moles heading to grams, and that should be in that first box. Mole to gram. All right, let's try another one. How many moles, so that's the question, are produced from 58 grams of oxygen gas? What kind is this one? Mole to gram, gram to mole. Or what do you think? So think about where we start. We start with the number. Good, exactly. Gram to mole. So we're going to take our gram right here to mole. We're going to put that right there. Okay? All right. Next, how many grams of hydrogen gas? So again, we're not even focused on that part because I don't need to know that. I just need to know that you guys know how to recognize these, right? So how many grams? That's the question part. So that's where we're going to form 8 grams of water. That's what we're starting with. That's the part that you would pull and put straight into your stoichiometry. Good. Somebody just said it. Gram to gram. Exactly. We have grams and grams. So that's what we're doing. Gram to gram. So if you're kind of catching up, if you're, I don't know if anybody's Wi-Fi slow or anything, but we have mole to gram to mole, gram to gram. All righty. Next, how many moles of KClO3 must decompose in order to produce 9 moles of oxygen gas? So we see the 9 moles with the number, right? So that's where we start. So grab the number first. We're starting with the word moles. We're ending, so how many moles? So this is a mole to mole question. Yes, exactly. Good job. So we're going to grab moles to moles and put that into that next box. All right. So looking at the next one, we have 9 grams. We need to go to how many moles? So what kind is this one? Perfect. Good job. Gram to mole. Remember, all of you guys have access to the direct chat. You can just type it in or you can unmute and shout your answer. All right, so grams to moles. Good. Okay, the next one, it says, let's find the number first. So blah, 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 blah. Oh, there it is. All right, 25.0 grams. Okay, 25.0 grams. And then it says what mass? What mass? So grams is where we're starting. So we know it's one of the grams. Where are we ending? What am I talking about with what mass? Good. Nice work. Good job. You got it. It's gram to gram. Good. All right. So gram to gram for that one. All right. Last one. Let's end this well. So it says how many grams of oxygen are produced when 3 moles of potassium chlorate decompose completely. So once again, we're going to go through the question. We find there's my number. That's where we're starting. So where are we ending? Good, grams, good. So this is a mole to gram, mole to gram. Nice work, you guys. Good job. I'm hoping it's starting to help a little bit, or it's starting to trying to remember some of it. The reason I put this question as number 2 is so that you can go back to it, all right? And then just for recording purposes, if you are from first period watching this video, yours is number 8, just so you know, okay? All right, so you guys have this question now to refer to, okay? So on these next questions, you have this one there that you can come back to, and you have all the setups right there in front of you, okay? All right, let's do number 3. I'm going to do 3 more with you guys, and then I'm going to let you guys finish yours, okay? All right, so it says use the equation below to answer the question. So how many moles of H2 are needed to produce 1.25 moles of H2O? So where do we start? With the number, with the number. So we're going to grab the 1.25 moles H2O, goes in the first box. All right, so we see this little symbol, right? So we start with moles. We know that we're heading back to moles, right? So you could even go back to number 2 and say, okay, which one was mole to mole? There it is. So moles, this goes into your mole ratio, right? So on number 3, so we know that this is going to be our mole ratio. Good. Mole ratio. Alrighty. So what goes into these 2 boxes for the mole ratio? We said it earlier. It was your coefficients. Nice work. Good. So we need to look for coefficients. So we need coefficients from H2O and H2. So we have 2H2O, 2H2. So we're going to put the words down to the right. So moles H2O need to come down here. So 2 moles of that. We're going to cross that bridge. We're going to use the coefficients. We had 2 moles of H2. Again, that 2 came from our coefficients right here. Okay? Don't forget that. All right, then we're going to type this into our calculator real quick. Some of you guys are already looking at it and you're like, that's a 2 to 2. Yeah. All right, 1.25 times 2 equals that, divided by 2 equals 1.25. So it equals itself because we had a 2 to 2 ratio. All right, so 1.25, and there we go. All right, so that's number 3. You guys are going to handle number 4. So let's go to number 5. So again, we're on number 5 now. All right. Number 5 says, use the equation below to answer the question. So we have CH4. So this is a combustion reaction, all right? And on Thursday, I made you guys a lab that you'll get to see a gummy bear do a combustion reaction. So it'll be kind of cool. All right. So we have this combustion reaction. It says, if 1.95 moles of H2O are used, how many grams of CO2 are used? This is actually not the right wording. I'm so sorry. We didn't get to fix it. So produced, should say produced, but I wanted to show you this question specifically because we are on the same side of our yield sign, right? And you can do that. Remember, for stoichiometry, it's all about the ratios, right? It's the fact that it's a 2-to-1 ratio between these two guys, so you can figure out anything that you need. So just kind of keep that in mind. But back to what we got. So 1.95 is where we start. So we're going to grab that. We're going to put that into this first box. Okay. Mole ratio. So what number is going to go down here if we're talking about H2O? 2, exactly. So we're grabbing our coefficient from right here. We're going to put 2 moles of H2O right there. Okay? We're going to change into what they want us to change into. So we need to get to CO2, right? We need to get to grams of CO2. So we're going to put first our moles, because this is a mole to mole ratio. Okay? So CO2 has a 1 in front of it. Words are coming down to the right. This is our mole conversion. So remember, for our mole conversion, and again, you can go back to number 2, remember that our mole conversion is this, right? A 1 always on the bottom, grams, which is your molar mass on top, okay? So when you guys are going back to your questions, make sure you use that. Okay, so we have our 1 mole down at the bottom again, molar mass on top. So where are we going to look to figure out molar mass? Where do we pull that from? Good, the periodic table. Nice work. Hey, we're remembering stuff. This is good. Okay, so we have a CO2. So we need to do 1 carbon, which is 12.011, plus, and then we have 2 oxygen, so 15.999 times 2 equals, and we get 44.009. 44.009. So there we go. That's our molar mass. Then we would multiply across, divide by everything on the bottom. So 1.95 times 1 times 44.009 equals, and then divide by 2, divide by 1. We get 42.908. So there's our answer. Okay? All right, I'm going to do one more with you, and then the rest is for you. All right, so far you guys have to go back to number 4. You're going to go back to number 6. You can use what we did in number 5 to help you, okay? And then number 7 is going to be the one that I do with you. All right, so looking at this already, hopefully you're seeing that it is the lengthier kind. You know what? Actually, real quick, go back to number 6. All right, so this is actually grams to moles, okay? So please make note that your mole ratio is over here. Okay, so you can't actually don't use our number 5. It's opposite. All right. Okay, let's go to number 7. Let's just do this. All right, so we have how many grams of NaOH are formed from 54 grams of H2O. So we're going to put the 54 grams H2O into that first box. Remember, the setup is that we have our mole conversion right here, right? So we have mole conversion, which is just the 1 mole to molar mass. We have our mole conversion over here, which is 1 mole to molar mass again. And then this right here is our mole ratio, right? So I'm just going to leave that there. That way we have it to just remember things. Okay, so looking here, okay, 54 grams. So we're going to bring words down to the right. So what goes on the bottom, the molar mass or the 1? Molar mass or the 1? And again, we're on number 7 right now. Molar mass or the 1? The molar mass, exactly. So H2O. Ooh, who has that memorized? Told you guys remember this one. We have 2 oxygens and a water. What is that approximately? There we go, 18, good, good. So we're gonna put the 18.015 down here. That's our molar mass, okay? And we're going to, we have to have 1 mole on top. We're not changing characters, so we're still talking about H2O. So go ahead and put the 1 mole H2O up here. All right, this is our mole ratio, so we need to use our coefficient. So what number is gonna be on the bottom? A 2, exactly. So we're gonna grab that 2 mole H2O. Okay, we need to relate it to NaOH. So again, we're going to refer to those coefficients in the front, right? Sorry, I didn't mean to shift that. So we have, good, there we go, 2 moles NaOH up here. I'm going to bring words down to the right again. This is our conversion, so that means we're going to have the 1 mole NaOH. All right, so out of those 2, which one is the molar mass? Again, we're going to refer to our periodic table. So Na has 22.990. So if you have a calculator, I would type that in, 22.990. Hydrogen is 1.008. And oxygen is 15.999. All right, so out of these two, which one is the molar mass? Add all those together. There we go. Good job. All right, 39.988. Good. So now when we multiply these across, I'm just going to show you one more time how to multiply across, and then I'm going to let you guys go work on the rest of yours. So 54 times 1 times 2 times 39.998. Sorry, 988. I got the top row done. Now I'm going to divide by everything on the bottom. 18.015 divided by 2 divided by 1, push equals 119.86, which is our final answer. And there you go. Okay, so on that note, remember, I need you guys to complete number 4, number 6, and number 8. Be careful in number 6. It is opposite of number 5. All right, so use number 2. I just shouted a bunch of numbers at you, and I'm so sorry. Use number 2, though, or use the one where we went through all of these different types, okay? Use this setup to kind of help you put the ones in the right spot, all right? No shame in that. All right, so I'm going to let you guys go. If you need to chat, stay on. If you are going to go, then I will see you tomorrow. Stay warm, and just please just keep communication open with me. Let me know if I can do anything, okay?